Okay, let's look at the question number 5. So you have given the training examples, 4 training example, that is 1, 2, 3 and 4. We want to learn function fx is equal to ax plus b, which is parameterized by ab using squared error as the loss function. Which of the following parameter you use to model this function? So overall question is asking find the value of a and b that will be best fit to this given training set. So in question it is asking to use the square error function. You can use that, but I am not going to use that. But let me just give you an idea how you can use the square error method to solve this question. So first of all, you will have to find this thing, uh, that error squared for each training example. So summation from I is equal to 1 to how many training examples you have, that 4, right? 1 2 3 and 4. So you will have to calculate this. So here it will be a plus bx, that is fx, minus you what is estimated function, or minus what is actual value of y for ith training example, and you will have to take the square. So now what you will have to do, you will have to go through each option. So you will take a this and b this, right? So you will get the fx, or you can say a plus bx is equal to 1 plus x, right? Now what you will do, you will pick this first training example, and here you will find this value, right? This one. So x is for this ab, so x is here minus 1, so 1 minus 1 is 0. So if you calculate this, so for the first training example it will be 0 minus y is 0.0319 and a square of it. Now you will have to calculate for the second training example same way, for this 1 plus x. So x is 0, so here it will be 1 minus y is 0.8692 square. Again you will sum up the, for the third you will again sum up for the fourth one. So corresponding to a and b you will get some quantity here, right, after summation. Now again you will do for the b option, and here a is 1 and b is 2 for c and for d also. So after doing all these calculation, whatever the minimum you will get, you can say that that will be the answer, because you will get the minimum square error. uh, so whatever option gives you the minimum calculation for this, that will be your answer. I am not going to approach via this method. So what I will do, I will go through using normal equation in matrix form. So maybe that will fetch the answer quickly. So let's try with that method. Okay, so how we can approach is, we know that the parameter value, how we can find the parameter value ab is equal to, let's suppose that the you have kept the feature vector as a matrix form, and that matrix is x. So x transpose x inverse and x transpose y. So y is this vector, so this is y, and x is, so x is 1 1 1 1 and minus 1 0 1 2. So this is your x vector. So let's first find out this quantity. So x transpose x. How you can write x transpose is 1 minus 1 0 1 2, and you will multiply with 0 1 2. So how much you will get? So 4 and 2 plus 1 3 minus 1, so 2. Here you will get 2, and 4 plus 1 5 plus 1 6. Now you have to take the inverse of this matrix, right? So let's take the inverse of this matrix. So 1 divided by determinant 24 minus 4 20, and 6 4 minus 2 minus 2. Now let's calculate this x transpose y. So your x transpose is this one. We are calculating x transpose y, and y vector is this one, right? This one. So 0.0319, 0.8692, 1.9566, 3.0343. Okay, so let's calculate. You can use the calculator. So you will have to add all these. So 0. Let me add it. So it will be 0.0319 plus 0.8692 plus 1.9566 plus 3.0343. So it will be 5.892. Now if you do the second multiplication, then 2 times this one plus 1 this one minus this. So let me do it. So 2 times 3.0343 plus so plus this term 1.9566, then minus 0.0319. So it will be 7.9933. Now what you will do, you will multiply these two, right? So this multiplication, this. So let's do it. Okay, so AB is equal to 1 divided by 20, 6 minus 2 minus 2 4, 5.892, 7.9933. So 6 times 5.892 is equal to minus 2 times 7.9933. So it is 19.3654, and this one 4 times 7.9933 minus 2 times 5.892 will be 20.1892, and this term divided by 20. So divided by 20 divided by 20, so it will approximately 1 1. So the correct answer for question 5 is option A. So you can also go through square adder method. Okay, now let's look one more question. Okay, let's look at this question number 11. So assume that feature vectors defining the trainee data are not all linearly independent. So feature vector defining the training data of x. So that feature vector, let's take that as a matrix x, that feature vector, and this x is linearly independent, not linearly. So it will have sub column, right? So there would be, these vectors are not linearly independent, that means they are dependent. So question is, what happens if we apply a standard linear regression formulation considering all features vector? So okay, so what we are doing is, we are in x, in feature vector, we have maybe some row or some column that are that depends on another column or row. So maybe this column is depending on this column, so all these vectors are not, if we are considering column vector, so all these vectors are not independent, they are dependent somehow. This information is given in the question. So it is asking that if we apply the standard linear regression formulation considering all features, so what, so let's check out the options. So x is full rank. Let's look at this question, option C. X is full rank. No, you will not get the pivot in each column, that is definitely sure. If it would had been the, if all the columns of this matrix are independent, then we would have got this full rank. But according to question, few of the vectors are depending on the other column, so we will never get the full rank. So this is incorrect. Now x transpose x is singular. X is singular. Why we are saying it singular? Because first of all, we have the, not all the vectors are linearly independent, so there would be some dependency. So when we find the determinant of this matrix x, then it will be 0, or we can say that inverse of this matrix will not exist. Okay, so what about the x transpose x? So if x is singular, then what we can comment on x transpose x? Is it singular? It would be. Let's take in any example 2 by 2 maybe. So let's take any singular, let's take 1 1, and if you take maybe multiple of this vector, so it will be 2 2, and you can see like it has determinant 0, and also this column are linearly dependent, so determinant of this is 0, so we can call it, this matrix is singular, right? Now let's calculate x transpose. So x transpose is 1 1 2 2. Now you can multiply this x transpose and this x 1 1 2 2. So what you will get is 2 4 and 4, and 4 plus 4 8. So 16 minus 16 0, so that is also singular. So option D is correct. Now let's come to this option B. Y hat is equal to x b hat is no longer the projection of y into column space of x. Okay, first of all let's talk about this b hat. What is this b hat? The coefficient b hat are not uniquely defined. So if you have already gone through the normal form, then it is easy to answer this question. So let's look at this option A first. The coefficient b hat. So coefficient b hat means that vector b hat is equal to b1 b2 till bn. Okay. Now how we find the parameters? So here that b hat is parameter. So how we find parameter? So x x transpose x inverse, and then x transpose y, right? Now the coefficient b hat are not uniquely defined. This is correct. Why? Because this x transpose x is singular, right? So we cannot find the inverse of this x transpose x. So you cannot uniquely define this b, right? If inverse of this is not existing, then you cannot define the b uniquely. So there might be, so that option A is correct. Now look at this option B, y hat. So what is this y hat? So this is actual y, right? So y hat is nothing but the projection onto column space of x. Okay, so y hat is no longer the projection of y into column space of x. Okay, so y hat is equal to x. So y is equal to x b beta cap. Okay, so if so y hat cap is no longer the projection of y into column space of x, we cannot say it, right? Is no longer, because if x is linearly, if x is not linearly dependent, if some of the, okay, so then there would be some combination that so okay, no longer the projection of y into column, that we cannot definitely say, right? So according to me, that A and D is the correct, other B and C is not correct. Okay. We'll look more question in another video.